Hello students, today we will solve question number 6 and 7 from the exercise of chapter 9. Question number 6. A stone of 1 kg is thrown with a velocity of 20 meters per second across the frozen lake and comes to rest after traveling a distance of 50 meters. What is the force of friction between the stone and the ice? So here, mass of the stone m is equal to 1 kg and initial velocity, which is represented by u, is equal to 20 meters per second, and final velocity, which is represented by v, is equal to 0. Why? Because it comes to rest. And distance covered, which is represented by s, is equal to 50 meters. So here we need to find out the acceleration. So according to third equation of motion, v2 is equal to u2 plus 2as. So v is, we know that it is 0, u2 is 20 square plus 2 into a, acceleration we do not know, into s is 50. So it will still be 0. 20 into 20 square is 400 plus 2 into 50 is 100a. So this 400 will go to the other side and become minus, and we have only 100a here. So we can write like this: a is equal to 400 minus 400 by 100, and if you cancel, you have only minus 4 meter per second square. So now we have to find out the force of friction, and we know that the formula of force equal to mass into acceleration. So F equal to mass, we know it is 1, into acceleration is minus 4. So if you multiply these two, we get minus 4 Newton. Newton is the unit of force. The minus sign here indicates that the acceleration is acting against the motion of the stone. So the force of friction between the stone and the ice is minus 4 Newton. Question number 7. So here, this is an engine which is 8,000 kg, and then this engine is pulling 5 wagons. Each of them is 2,000 kg with a force of 40,000 Newton. And along the horizontal track they are pulling, so the track offers a frictional force of 5,000 Newton. So we are asked to calculate 3 values. The first one is net accelerating force. So force exerted by the engine, that is F, is equal to, we know that it is 40,000 Newton, and frictional force offered by the track, F, it is 5,000 Newton. So here we have to calculate the net accelerating force. So FA. So we have to subtract these two forces. So F minus F. So the force of engine is 40,000 minus force, frictional force is 5,000. So if you subtract this one, you will get 35,000 Newton. So the net accelerating force is 35,000 Newton. Now in the second case, we have to calculate the acceleration force of the train. So this engine exerts a force of 40,000 on all the 5 wagons. So the engine exerts force of 40,000 on Newton on all the 5 wagons. So we have to first find out the mass of all the 5 wagons. M is equal to mass of 1 wagon into number of wagons. So what is the mass of 1 wagon? It is 2,000. And what is the number of wagons? 5. So if you multiply, you get 10,000 kg. So the total mass of all these 5 wagons is 10,000. Now we have to find out the total mass including the mass of engine itself. So mass of wagons m plus mass of the engine. What is the mass of engine? It is 8,000. So 10,000 plus 8,000 is equal to 18,000 kg. So the total mass of this engine and all the 5 wagons is 18,000 kg. So we are supposed to find out the acceleration of the train. So we know that force is equal to mass into acceleration. So we can also write it like this: acceleration is equal to force by mass. So the net accelerating force is 35,000 by mass 18,000, including all the 5 wagons and the engine. So if you cancel this, you will get 1.944 meter per second square. So the acceleration of the train is 1.944 meter per second square. Number C, the force of wagon 1 on wagon 2. So here we have to exclude the mass of wagon 1. So mass of 4 wagons, excluding wagon 1. So we get each of the wagon is 2,000 kg and we have 4 wagons. So if you multiply, you get 8,000 kg. So mass of the 4 wagons is 8,000 kg. We already know that acceleration is 1.944 meter per second square. So the force of wagon 1 on wagon 2 is equal to m into a. So what is the mass? 8,000 into acceleration is 1.944. So if you multiply, you will get 15,552 newtons. So the force of wagon 1 on wagon 2 is 15,552 newton.